So welcome to question 3 on a 2022 graphics paper. So shown below is a 3D model of an action camera. Here's our 3D model. Also shown is a diagram of the LCD panel on the back surface of the camera. So this is just the screen on the back of the camera. And it displays the power level. So here's our power level, our Bluetooth, and our Wi-Fi connection. Okay, all things you would see in everyday life, on your phones probably. Part A. The outline of the power display is shown below. So here's our power display, similar to the one we've been given. Shade the display to show the power at 80%. So we'll imagine the whole thing is 100%. Okay, and we've got 1, 2, 3, 4, 5 sections. So I'm going to divide that by 5, and that gives me 20%. So each one of these is 20%. So we have 20, 40, 60, 80%. So I need to shade as far as that section. Okay, so using our colors here, you can use whatever color you want. We're going to shade this display. Okay, so once it's nice, neat and tidy, you can shade this all the way up along. If you want to, you can add, maybe go from dark to getting slightly lighter, so I'll go over that a little bit heavier. So it's getting slightly lighter as I move up along. Just being nice, neat and tidy. That's all we're aiming for. Okay, so that's my battery display shaded in. Next up then, part B. The camera has Wi-Fi connectivity for uploading photos, and we saw that there. The drawing across shows the logo for a wireless connection. So here's our wireless connection. Divide line AB into 5 equal parts. So we want to divide AB here into 5 equal parts. We can see 1, 2, 3, 4, 5. Okay. And complete the drawing of the wireless logo. So we'll start with dividing into equal parts. So we can draw from A or from B, doesn't matter. Okay, I'm going to draw a line at any angle. Okay, I'll just draw there, approximately. Okay, any angle you want. I'll get my compass. I'll set it to any distance again, but just I want to be conscious that I'm going to step this distance out 5 times. So I want to keep it on the sheet. So 1, 2, 3, 4, and 5. Now I always number these just to make sure I've got the correct amount. So that's great. Now the important line is joining that final point back to B, because now I'm going to use sliding set squares to draw parallel lines from each of my other points. Okay, so I've divided line AB now into 1, 2, 3, 4, 5 parts. And lastly, we want to complete the logo, so those are all arcs. B is the center of the arc. So we'll go to B, set it to that first distance, swing an arc, up to the next one, swing an arc, and if we need to go back, it's making sure we're putting pressure through B, that we don't let our compass slide. Okay, and show our constructions. That's our construction shown. Nothing there about shading or rendering, so I can finish that one. Part C. The camera has Bluetooth connectivity to enable it to Connect to other devices. Shown on the right is the outline drawing for the Bluetooth connection symbol. It is based on a regular hexagon. Okay, so I can see there running around the outside of that, I got my 1, 2, 3, 4, 5, 6 sides. Okay, and they're all of equal length because it's a regular hexagon. Complete the drawing of the Bluetooth symbol below. So they've given us the length of one side, PQ. Now we need to start talking about the makeup of a hexagon. So we've got, normally, let me just draw this, you might have drawn a hexagon like this, right side up. Okay? But now we're drawing it on its axis. So we're rotating this down, okay, till it's in this position. Okay, so we're rotating it halfway down. Right, and let's show that outline. So we're going to there. Okay, so instead of it being a 60 degree external angle, we're going to be dealing with a 30 degree external angle. Okay, and we can see that. We can come back now and use my 30 degree set square, and we can see, yes, that's a 30 degree line. Okay, so I'm going to go at 30 degrees this direction, and I'll draw a vertical line up from Q. Okay, and we know it's a regular hexagon, so the length from P to Q will be the same for all sides. So we'll show that, rotate it around, and P to Q will be there also. I'll draw a vertical line. I'll go at 30 degrees back this way because this side and this side are parallel to one another. And compass, let's find that side and that same side for our regular, pentagon. Okay, so I'll come along. I'm going to do this in blue, but you can just do it in your regular pencil. Just want to show it popping off the page a little bit. So PQ, go over that with my blue here. Okay, P directly up to the opposite side, or opposite corner. Right, I've got 30 degree line and a 30 degree line. Join those diagonals. And finally I've got the heavy in that line. Okay. Alright, maybe it's not that clear on my drawing, so I'll go back, forward heavy, just so it stands out off the page for you in the video. Okay, so there we have it. So complete the drawing of the Bluetooth symbol, done. Nothing there about rendering either. So part D, shown on the right is the action camera mounted on a tripod. So we've got our tripod here, three-legged stand. The tripod is based on a triangular based pyramid. So we've got triangular base here for our pyramid. Shown below is the outline, elevation and plan of a similar tripod. So we've got basically the plan and elevation of a triangular based pyramid. Part 1. Complete the indexing of the elevation from the plan. So we need to index these points up here. So O is in that center point, so O is kind of that point up there. So I'll follow it up. Here's my point O. Then all other points for my triangular-based prism, okay, or pyramid, are on the ground, okay, or on the horizontal plane on our XY line. So A is on the XY, C is on the XY, and B is on the XY. Right? And just to show the projections of those, so I can show B and B, they're the same point. C and O project up there, and A projects up there. Okay? So there's my indexing. I've got 1, 2, 3, 4 points, 1, 2, 3, 4 points. Part 2 then, find the true length of the leg AO. Alright, now, based on what your teacher might have done, you have two methods for this. Okay, one is a rotations method, and the second is an auxiliary elevation method. So I'll show you both very, very quickly. So, rotations. Okay, I'm going to rotate AO in plan until it's in that position. So we're looking like that at our measurement, or sorry, of our line, and we're going to rotate it so it's like that. So then when I look at it, I'm going to be looking at it perpendicular and get that true length of it. So A to O, let's rotate that there. And I'll use colour here to highlight this also. Okay, so I've rotated that there. Now, the height of A hasn't changed, so it's still going to be on the XY line. So project that up. So that has been projected up there. And now O down to my A having been rotated. Okay, so that is the true length of OA. Okay, so that's one method, my rotations method. Second method then is going to be auxiliaries. Okay, so this line is at 30 degrees, which will make my life a little bit easier. I'm going to come out here anywhere and draw an XY line. So just approximately there, right? And that's called the X1, Y1. And I'm going to project out perpendicular to my AO and my XY line. So that's going to be at 60 degrees, so project that out. And project out A also. Now, because I'm projecting from plan, right, same way as if I projected from plan here, I create an elevation. I'm projecting from plan again, so I'm creating an auxiliary elevation. Okay, and elevations share heights. Okay, same way an elevation and end elevation have the same height. So let's go through it. Point A, the height of point A is 0, it has no height, it's on the XY line, so that is point A. Right? My point O then has a height of that, and I'm going to follow it down to O up here. It's going over my drawing a little bit, but there we have O, and I'll just use a different colour just to highlight this, but it's the same measurements. There's O to A. I'll label O there. So this is also true length of OA. Projecting out there, and that's at 90 degrees. Okay, so as I said, either your rotations method or your auxiliary view method, both are acceptable. Both will give you full marks. So we'll flip over the page here to the last part of question 3. Okay, it's part E. In this question, they have the image below shows the design of a similar action camera. So here's our action camera again. Draw Part 1. So we always go in the steps they provide. Okay, don't start on plan if they give us the elevation first. So part 1, an elevation in the direction of arrow A. So in the direction of arrow A. Plan projected from the elevation. So we're going to have our elevation, our plan underneath it. The end view in the direction of arrow B. So B looking in from this side. So it's projecting onto a surface over here and rotating out. So it's going to be elevation, plan, end view on this side. And then determine the true shape of surface S. So we've got surface S here. That's the one we have to find the true shape of. Okay, and we can do that similar to the last question, through rotation or through auxiliary elevation. So let's get cracking with that. Now I need to make sure that I'm going to fit my drawing on this page. So let's look at the overall height. Let's do a little sketch here. So I'm going to have my XY line. Okay, the overall height of this is 70 plus 20, so it's going to be 90 high. Right, very basic kind of sketch of it here, just to help me plan it. Something kind of like that. Right, my plan will be underneath that, so I'll project down to show my plan. Keep a distance of about 10 or 15 mil between them, and the depth then of this is 20 plus 20, so 40 overall. And then I also have the lens coming out, which is another 20 and another 20, so that's another 40. So that's going to be projected down, something like that, like that. Alright, and sloping surface. Okay, so something kind of like that, and then my end view, projecting up at 45 degrees. Or whatever method your teacher uses, might be rotating it. Okay, so I got 45 degrees, some teachers rotate, some teachers have a 45 degree line and come out and up. So whatever method works for you. So we're going to have sloping surface, edge coming there. So there's going to be a little bit of a tricky bit there. I have my lens and a lens. Okay, and that distance then. So overall width, we've got 25, 35, which is 60, plus 50 is 110, plus 20, 130. And this overall width, I just do this because I can make sure I fit on the page then before I begin. So we've got the same overall width, which is going to be 80. So overall height, overall length, overall depth, we have then. So I need to come down more than 90. So if it's on the page, I'll come down 120, which should be loads. Draw my XY line. Like so, it's my X, Y. Okay, I'm also going to be doing a construction here for surface S. I'll probably do a rotation method just because it's quicker, but obviously, and it won't be, I'll talk through the auxiliary method in a while, but you'll see why. Okay, I'm going to come over a little bit of a distance so I've got space for that rotation, and let's get cracking here. I'm going to mark my overall lengths first of all that I'm going to need. So I have 20. Said total is going to be 130. Any other distances there? I've got a 25. I've got a 35. 50. Is there any other lengths? I'm going to have to find the centers of those circles also. Okay, I'll get to that in a while. Right? So let's project vertically up and down all those lengths, because I'll need them for my plan view also. Okay, overall heights then, let's step off my 70. And there's another 20. And the other heights that I need. Don't have a height for that, I'll find that in a while. We're going to have a height obviously for the center there. 20. Okay, so draw those across, and I'm just going to project them across because I'll need those similar heights for my elevation, because elevations share heights. So I'm going to draw what I can now of the front elevation. Heavy on either side. Then I'm back. There's my slope. Okay, and draw my heavy line for the base. And that top element. And I've got my shape S, which was 20 in. And just looking here on that, figuring out this little 20 that I've marked off, there's going to be an edge running down the back of my shape, so I'll put that in now. That's going to be a hidden detail line. Okay, and I think that is everything. So onto my lenses then. We can see that it's radius 35 and radius 25, and the distance down is there. So if I'll add in a few little marks here just to show you. So the distance from there to the center is 35, okay, because that's the radius 35. So from that 50 mark that I have, I'm going to measure in 35 and draw a line vertically down. 35, and we'll draw a slight line down. Okay, then we can see here if we come down 20, that is going to find me the top of the lens, okay, but then it's another 35 down to the center. So if I come down 20, that line is coming across March 20, so I come down another 35 on that. Alright, so let's get my compass, set it to that radius 35. And it's actually going to touch the top and bottom and side. Okay, so it's tangential to all those edges. Okay, so that's my circle, and then I've also got radius 25. So compass, set it to radius 25, and draw that smaller lens. Okay, so that is all of my elevation. Now let's come down, like I said, leave a little gap of about 10 or 15 mil. Okay, I'm not even going to measure it. I'll just draw my light line there for the back. Okay, and I'll measure off my overall depth of my object. Okay, so going in order, I suppose again, I have elevation done, now I'm on to plan. So we've got 20, 20, 20, 20. Let's measure off all of those. Should just about fit on the page here. So and seeing as I've marked those off, I'm also going to just project them up at 45 degrees. As I said, you use a method that your teacher uses with you in class every day, which could be rotating these distances. Okay, so it could be rotating them, or it could be 45-degree line here and you come out to meet it and directly up. All of those methods work. And I'm going to extend these up then, because I'll use them later for my end elevation. Okay, so let's do the main body first off. So I've got an edge for there, but then I've got surface S, so edge there. Okay, my back edge is going to be running along until I get to that 20 mark, so to here, and then that's going to be to there. So let's go heavy along. And back edge there. Next up then I've got edge coming down, got my S, which is 20 and 20, so that'll be the position of S. And here we have main body. Okay, next up let's do that red little, I suppose it's the button or maybe a flasher. So we've got that extended down. Depth is going to be the same depth we have here. We follow that line down, it's that 20 again, so there's my 20. Okay, so that's my flasher, and I need to show that edge continuing on, to show the change in height there. Alright, and onto my lens then. So, I've already projected, I just need to project down smaller lens. Okay, so let's go with 20 depth each, so let's extend this out. Extend this out. That's the first lens, the larger lens looking down on top of it, and the smaller lens. Is there. Okay, and now we're on to our end view. So I've projected all those up at 45 degrees. So let's start drawing in my body, okay, the main body. Main body, overall height, right there. Okay, and I'll come back to the main body in a sec just to show you why having all views are important. Okay, let's finish off the lens then. So the height of that lens. Touching the base. We've got smaller lens, extend out. Heavy. Okay, so let's look at this red element first of all. So looking in, I can see this rectangular surface. So that is an edge view of there. We know it's going to be 20 wide, which we established already. So let's project that over. That is going to be the position of it there. And draw that heavy. So that's that lens. Okay. Next up we've got S. So here's surface S, here's surface S. Okay, we know it's going to start there, so that's going to be the first part of it. Running up, that edge represents this edge here. Alright, and now we also have this point. So we're going to bring that across to locate that point, and I can draw that in. So that's my point S. And just to finish it off, I'm also going to have this edge. So let's show that edge. And then a small little detail. Okay, we discussed this slice that's been taken off. That also is going to have an edge running down the back of my shape. Okay, that edge is in line, it's 20 in, so it's in line with this one. But there's going to be a little opening there for us to see some hidden detail. So a small bit of hidden detail there. Alright, so that's our part 3 completed, our end elevation. Okay, then last bit, determine the true shape of surface S. So here's surface S. Alright, I'm going to highlight it with pen. Pencil. So this is surface S. Okay, so we have the true width of it. Right, this is also surface S. So I've coloured in my surface S in all 3 views. Now, I said we could do an auxiliary view for this, so XY line perpendicular to it, but we're projecting out here onto our existing views, which would be a bit awkward. We could go back here, but same again, it's just not really out of space for us. Okay, so what I'm going to do is I'm going to do my rotation. So I'm going to rotate the edge view of that surface. So just to show you in 3D what I'm doing, I'm rotating this around so that I essentially get the plane there, so I'm looking perpendicular to that plane in elevation, to that surface in elevation. So rotating it around. Okay, so that we're perpendicular to it. Okay, so that's been rotated. Now stand that up then. So that's the position or width of it in elevation. Okay, and just to make life a little bit easier and you can follow it a little bit better. Okay, I'm going to call this point 1, point 2, point 3, and point 4. Okay, so here's 1, 2, 3, and 4. So we've rotated the object around point 1, 4, or edge 1, 4. Okay, so that's our axis of rotation. Okay, so they're going to stay in the same position. Right, so there's 1, 4. Right, and it's essentially rotated around, so it stays in the same position. So I've got 1, 4, and here is 2, 3. Alright, so 1 and 4 stay in the same position. 2 and 3 are the ones that I've rotated around. The height of 3 will stay the same, so that's going to be my new 3. And the height of 2 will also stay the same, so I need to project that out. So here we have the outline then of that surface. So 1 and 4, 2 is there, and 3 is there. I'll just use my pen to mark that in. Okay, so right along here, drawing true shape of S. Okay. Right, so that is all of question 3. Question 3, one of the longer questions there, doing everything, or particularly our orthographic question, which we should expect to see every year. Okay, so stop there.